So we started out talking about chemistry, and while we are still in the kind of science part of environmental science, we're moving away from the little stuff and going to the bigger stuff. So your assignment on Canvas for tomorrow is one that I enjoy. It is about it is about Earth's spheres, so geosphere, hydrosphere, all that kind of fun stuff, atmosphere, how we divide up the Earth. And today we're talking a little bit more about that kind of stuff, but how essentially we break down what happens on the planet so we can study it. Because humans like to make things all nice and even, and likes to divide things and categorize things. So we are talking about systems. We're gonna kind of take a step away from like the concept map format. I'm still gonna write everything out. If you want to continue doing concept maps, you can continue doing concept maps, but we're gonna try to stick to kind of more traditional bullet points. So a system is simply a network of relationships among parts, elements, or components that interact with or influence one another. That is our kind of textbook definition of what a system is. There's a bunch of parts working together to create a whole. So if you think about the school has a lot of systems in place, getting you from one class to the other, how schedules work. Computers are almost all systems. Car engines, example of a system. All these parts and pieces that come together and interact and influence one another usually have a specific outcome. We're gonna make this real long. We'll back up. All right. So, if everything is interconnected, where do we start and stop? If it's all a big circle, how do we know what to include in the circle? If everything's all complicated, because life is always more complicated than we think it is. If everything is interconnected, where do we start and stop? What do we include in the system? What has enough influence in order to be considered a part of the system? And that's where focus comes in. Perspective defines the system. Whoever is observing, whoever is explaining, whoever is illustrating gets to decide what is included in a system and what isn't included in a system. Where it starts, where it stops. The person who observes the system is the person who defines it. Very beauty is in the eye of the beholder. Systems Systems can exchange energy, matter, or information. So if we have a bunch of systems, think of it like this, right? You have your digestive system, right? Food comes in, stuff comes out, digestive system. We suck up all the nutrients we can, we get rid of what we don't need. But we also have our circulatory system, all of your blood vessels going from your heart into your toes and all the way back up. They're two separate systems. We've got our digestive system, we've got our circulatory system, but they can work together to form one giant system, which is us. So it depends on what we're looking at. If that's using our bodies as an example, we can think specifically about Earth's systems. So we have energy inputs, right? Where do we get our energy from on Earth? It all comes from one place. All energy on Earth at one point in time came from the sun. When we talk about how we interact with the world, solar energy is up there. So we got solar energy. We can also harness geothermal energy. Life processes. And human activities. All of which are energy sources that affect the Earth. All energy comes from the sun, but the energy that we exert affects the environment. An example is the Gulf of Mexico. So we've got our input, right? Mississippi River, M-I-S-S-I-P-P-I. Haven't spelled out Mississippi since second grade. So, Mississippi River is the next word on this sentence. The Mississippi River feeds into the Gulf of Mexico. We get things like fresh water, sediments, and nutrients, but also pollutants. Those inputs from the Mississippi River, other rivers that also feed into the Gulf, as well as like the atmosphere, gets put into the Gulf and taken out by shrimpers and fishers. So we have our outputs. They are shrimp and fish. And those enter Human digestive systems. So we've got our initial system, right? Our Mississippi River feeds into the Gulf, and the Gulf produces these shrimp, and it's kind of like a one-way system. It's not closed. It's not a circle. It's not a cycle. And then we have the outputs of that system affecting another. So systems are interchangeable. Systems can put into and take out of one another. It's not the page I need to be on. I'll write that down for a second. Any questions about this? It's going to be kind of messy. Energy inputs, energy outputs. We're going to talk about a different type of system, and those are feedback loops. There's two we're going to talk about, and they are positive feedback loops and negative feedback loops. Positive and negative feedback loops are everywhere. Once you get this down, you can relate a lot of stuff in your everyday life to positive and negative feedback groups. So, in a positive feedback loop, we are driving a system towards an extreme. Essentially, this is the opposite effect of a negative feedback loop. So, if positive feedback loops drive a system towards an extreme, negative feedback loops stabilize. So, an output moves in one direction, and acts as an input to move the system in the opposite direction. It stabilizes. I'm going to go through two examples. Once I get more space on the board. So, in a positive feedback loop, we are always going in one direction. Something happens, it makes that thing happen again and again and again and again until eventually we reach an extreme. In a negative feedback loop, something happens, whatever comes out of a system goes back into the same system to push the system in the opposite direction. It'll be more clear once I explain it a little bit. So, we think about negative feedback loops. The example I'm going to use is temperature regulation. specifically in the human body. Be cool if I follow up a little bit. Let me know if you don't get this stuff. So, if we've got our brain, right? That's your brain. I know I'm a phenomenal artist. So, let's say you're too hot, right? That will send a signal to the brain. The brain says, okay, we're going to sweat. And when you sweat, you cool. But uh-oh. Now you're too cold. That signal goes to the brain. Your brain says, okay, we're going to put on more clothes. Or shiver. Then we're going to warm up. But uh-oh. Now we're too hot. And it kind of goes in that circle in kind of less extreme fashions until you've kind of stabilized in temperature. So, negative feedback loops. You have a stimulus, you create an outcome. The outcome results in the opposite of what that stimulus is. So, if you're too hot, we make you colder. If you're too cold, you get hotter. The example we're going to use for a positive is erosion. So, let's say step 1, banks on a river. Are cleared and start to erode. Somebody drove their truck down the side of the river and loosened up all that, the plants and stuff. Or just we had a really, really big rain, and that rain washed all of the plants off of the riverbank, right? Now, water and wind expand and erode the soil. So, we've got a bunch of loose areas now. The water's going to erode it and then loosen more around it. Step 3 is more erosion and plant loss. And this just keeps happening. It keeps happening and keeps happening. Our positive feedback loops push us towards an extreme. It's really easy to mix up the difference between positive and negative feedback groups. Does anybody have any questions? Okay, let's see. Our systems examples, the ones that come up a lot in environmental science, are Earth's spheres. We've got the geosphere. Geo means land, so that's our rock stuff. Our lithosphere. That's like our geosphere, but a lot lower in Earth's crust. Our biosphere, that's all of our living things, the system in which all living things on Earth are contained. Probably the one you hear the most often. Atmosphere. That's, yep. Atmosphere. All of our air that we breathe, our greenhouse gases, our ozone, all that fun stuff. And our hydrosphere. That is all of our water on Earth. Everything from the stuff I've got in here to the polar ice caps, all contained in the hydrosphere. So, any questions about Earth's systems? Okay. So, tomorrow on Canvas, you will be doing more in-depth stuff on Earth's spheres, specifically the geo, atmo, bio, and hydrosphere. Get a little bit of info on the water cycle, answer some questions there. After that, we go into nutrient cycles. So carbon cycle, phosphorus cycle, nitrogen cycle, all that fun stuff. Then next Friday-ish. Yes, next Friday-ish. So the September 3rd, September 4th, we're looking at some sort of quiz over spheres and cycles. Not a test, but just some sort of assessment. And then we get to go into ecology. So if you open up your Chromebooks and you get on Canvas, there is a link in the Earth Systems module titled Systems Exit Ticket. I need you to fill that out right now before we leave today. Systems Exit Ticket. Thank you, thank you, thank you.